Hello everyone, in the module number 9. This is a module in which we will take a look at two very nice features that has been added mostly because they are nicely supporting code generators. And code generators are by itself super important and interesting and powerful features that has been added to C#9. So we will take a look at them also, in the context of those two features that has been added. So the first feature that has been added under this overall umbrella term of supporting code generators is a support for new features for partial methods. But before we can move on and should move on to partial methods, let's take a quick recap about partial class. Partial class is something that we had in C# for years, maybe even from the very beginning. So partial class is just a way of splitting a definition of a class into multiple parts, into multiple files typically. Although they may be, those parts may be in a single file, but this use case is probably not very often used. So imagine that you have a class A and it has two partial definitions. And this is how it is working. Class A is now split into two definitions. And the resulting type is just a sum of all parts that are defining it. And this includes all things like base types, interfaces, attributes, and so on and so on. Obviously, it also is about fields and all members. So all the methods and all the fields, all the setters, getters, properties in general are summed into a single class from all those partial definitions. So, as I said, for example, if a partial class A is set to implement IDisposable, this part of class A, then another part of it, which will be another partial class A, may implement it, so it may have this dispose method, which is required by the IDisposable interface. It also may, for example, derive from one type, like here, it is deriving from the generic list collection, and also it has serializable attribute. So in the end, we have a class A defined in those two partial parts that defines a class A, which implements IDisposable, has a serializable attribute, and also its base type is list of T. In this case, a list of int. What are benefits of partial classes? First and the most important one is that we can separate some parts from another. So typically we can separate auto-generated code from the code that has been manually written by us. And if you have ever used Windows Forms framework, this is the reason for partial classes mostly. So imagine you are writing Facebook 2.0, a new better one, and then you have this form that you have defined and it has some buttons with some properties. Obviously, a real application will have much more UI elements. And then you define all this interface in the Windows Form Designer, which is a very nice UI tool for designing interfaces. And then such a form is backed by code, which means simply that this form is represented by a class. And then we have two files, one for this manually written code, so you will have a partial class main form, and there you will be putting your event handlers, like here we have a handler for dislike click, and it is a code that we are in charge of. We can change this code and nothing will be overwritten here. On the other hand, there is this auto-generated part of class main form, so it is in another mainform.designer.cs file, and it will contain huge region of all things that is defined in your Windows Form Designer. So all the automatically generated code will be there. So in the end, we have this nice split between the code that has been defined by you and this which is just auto-generated. And this is the partial class most important benefit and the feature, and they are introduced mostly because of that. You can also ask, okay, partial classes exist, but do I have possibility to use it for structs? And yes, you can also define partial structs. So it works for partial structs, but here we have a little bit of problem because now structs are different, because when you use a managed class, you don't care about the order or the fields, because we assume that the order is automatically assigned, and we don't care because it is used only by the managed code, and we really don't care about the order of all the fields and methods in the metadata. On the other hand, when you create a struct, maybe it may be used by unmanaged code, so the order of the field will be important because the unmanaged code may expect some specific order of the fields inside the struct. But now you have partial struct, which is a struct splitted into two definitions, and we really don't care what will be the order of those fields, because now the order depends on the order of the partial definitions. So in the end, it will compile, but it will produce a warning that it is a problem because there is no defined ordering between fields if you have fields defined in separate partials of a struct. And the advice is to specify all fields in one part. And leaving things like that without this advice being applied, it is just an undefined behavior, because now we don't know what will be the order of the fields. The order of the fields in the end will depend on the order of the partial structs definition, so in the end it may depend on the order of the files in the project or in the directory, so it is really something that we should not rely on. Okay, so we have covered partial types like partial class or partial struct, and now let's move to the partial method thing. And partial method is maybe something a little bit confusing, because while we are describing partial class, it is pretty easy to understand the concept. We have several parts of the class and it's all merged into one class. But what does the partial method mean? And moreover, partial methods are supported before C#9. And what does it mean? First of all, if you would like to use partial method, it must be also inside a partial class or type, because it is saying that it is something probably splitted somehow. So it must be in a partial type. And partial method is just for saying something like this method may be not implemented. So we are saying, okay, this method is here, but it may be not implemented, and introduce some kind of optionality whenever we are using this method or not. So when you have a partial class C, for example, and there you have a partial do something method, it is for saying that. This is kind of optional method, so it may be not implemented. Moreover, it is even possible to call such a method from our regular methods. So as you here see on the slide, you have use method, which is just calling do something method, and it is totally fine. So it will compile and it will be just running, depending whether the something method is provided or not. When I'm saying whether it is provided, I'm saying about the implementation of do something method. So if do something method has an implementation defined somewhere else in another part of class C, it will be just regularly called by the use method. If it is not defined in any part of class C, then okay, then it will be not called, and the call to do something method will be just removed from the use method. So as you see, it really provides kind of optionality. We have a do something method that may be used and called or not, depending whether it is implemented or not. So it is really optional way of treating a method. There are some restrictions, however, mostly because of this fact that you can call it and we don't know whether it will be implemented. So first of all, such a method, the partial method, and I'm always saying here about partial methods before C#9, they needs to be private to reduce the optionality. So we can only call our partial method from within our type, to not explode with this optionality outside the type. Moreover, the method must be of void return type, so it must return nothing, because it would be then a problem if the method would return something. Then we don't know what to do in case if this method is not implemented. What value should be assigned to something if we are just going to remove the whole call because the method is not implemented. And exactly for the same reason, there is no possibility to use out parameters, because what will be the value of it if we will just get rid of the call because the method is not implemented? So as you see, before C#9 there was a partial method feature, but it is pretty limited and can be treated as a kind of saying, okay, this is an optional behavior, this is an optional code that may be not implemented, and then it will be not called at all. So for me it is something for like logging or any other optional code that is not crucial for our application. So let's move to the partial methods in C#9, because they are something a little bit different that we have just described. First of all, in C#9, all the restrictions that I've mentioned were removed. So now we have no these restrictions when talking about partial methods in C#9. But there is a huge difference. We don't have this optionality. Now it simply means that the implementation is required. So if we have a partial method, then we need to provide its implementation. It might be pretty strange to have such a feature, but you will see why it is beneficial, especially in context of code generators. We have now backward compatibility mode, because it depends and the C# compiler needs to treat the old and new behavior. And for example, if there is no accessibility modifier specified, like public or private, the old rules are applied, so the rules before the C#9, with all those restrictions and so on and so on. Otherwise, if there is an accessibility modifier, even if it is private, so in terms of the behavior it is the same as the previous partial method, but the accessibility modifier is provided, the new rules are being applied in C#9. And as you will see, this is a perfect fit for the code source generators in C#9. We will return to that in a moment. Just a few words about the compiler compatibility mode detection, as I mentioned previously. So the compiler will detect this compatibility mode and will give you a proper advice depending on the context. So if you are compiling it and the code in C#9, for example, and you will see, and the compiler will see that the partial method returns an int, then it will just comply and will say, okay, but it should have an accessibility modifier, because if a partial method returns something, it means it is running in a new mode, not the old one. So we need to explicitly provide the accessibility modifier. And similarly, if you say, okay, your partial method is private and it retains void, so it returns nothing, it will just be saying, okay, it triggers the new mode, the new way of treating partial methods. So it will say, okay, this is a new way of treating partial methods, you have to compile it under C#9 to make it working. So with all those restrictions being removed, we have pretty much flexibility what can be used as a partial method. For example, a static method may be partial. There is no problem with that. It will be public, static, partial, method returning an int, for example. We can also apply partial keyword for overriding virtual methods, which will be kind of saying this method should be overwritten and its implementation will be provided somewhere else. Because it is saying that we are forcing implementing this particular override. And also we can apply it for async methods, because async is kind of implementation detail, although it is pretty big topic, and we invite you to follow the async expert course to see whole things related to async, but simply put, it doesn't matter for the for the signature of a method whether it is async or not. So we can have a partial class C when we define some methods. One may return void, another may return task of T, and the implementation of those methods may be provided in a different part of the same class, and they can be marked with the async keyword, which will have the same signatures but will allow us to call await inside those methods. And all this new way of treating partial methods is about the difference between the definition and declaration in the end. So declaration of a method provides its signature. It provides the information to the compiler what is the name of the function or a method, what is the number and type of arguments, what is the return type of this particular method. So this is a kind of signature, declaration of something that is describes what is the overall shape of a given method. Then we have a definition which will be kind of confirming the same information, but also which will provide an implementation, so the real code will be attached to a definition. So in the end, this is what the new way of treating partial methods allow. We will have one part of class, partial class obviously, when we declare what is a method, what is a return time, what are the arguments of a method, what is the name of it. So it is a declaration that somewhere else in another part there is an implementation of it. And we are forcing it because the compiler will not compile the code if the implementation is not provided elsewhere in other part of the same class. So having this split between the definition and declaration, it is a perfect fit for source code generator scenarios, as we will soon see, and I already promised you. But before we move on, let's wait for a moment, let's stop for a moment, and let's give you a few words about all this source generators thing that is being added to C#. There is a great article introducing it with the title Introducing C# Source Generators, and they are about giving you more flexibility about the code being generated. So imagine that based on some external input like JSON file, CS file, or XML file or any other one, or even the source code itself, your source code in C#, then you have some possibilities. You have this input and external input and data or source code itself, and then during the compilation time you can plug your source generator into the C# compiler pipeline, which gives you this benefit that this source generator will be able to generate additional source code based on this data, whether it will be those external files like XML files, or maybe based on your own C# code. So in the end it looks like that. You run your compilation, then the real, let's say the main compiler starts to compile your code, the source generators are plugged into your pipeline, they analyze what's to be analyzed, like the external data, and they generate some additional new source code that will be also compiled during the main compilation. It is up to us what this source code, what will be the source code generated, what we analyze to do this source code, but it is all plugged into the main pipeline. And this pipeline of the compiler is then supported as a regular compilation inside your IDE like Visual Studio. You can imagine it as a kind of macro or any other way of providing a new code during you compile your own code. There are some characteristics of source generators. So first of all, they can only add code. You cannot modify your own code. That's why we require partial types and partial methods, because there will be part of your own code that is just your regular code that you would like to use, and it needs to be partial because source generator will generate another set of files, or maybe one file, logically at least, that is the another part of your partial class where you put, when the source generator puts the code that is being added to be compiled. And then in the end, this type is being merged, so your own code with the code which is generated by the source generator is merged into one file, into one type, and compiled as another type defined in your C# program. An important thing is that the source generator will see only the initial source code. The source generator cannot see the output of another source generator. In other words, we cannot chain source generators because it would introduce a whole new level of complexity, how they are chained, how not to introduce any way of source generator overflow exception that they are just stuck into an infinite loop. So it is just this limitation. Every source generator has as an input the original source code. It can additionally analyze any other data, and it will add a code to the initial data without knowledge what are other source generators adding to the same source code. Let's look at some examples of source generators. So first of all, a very typical example when we are talking about source generators is creation of serialization infrastructure for a type, for a data. So imagine you have this JSON or XML file, which is somehow added to the project itself. And then your source generator will be able to generate the corresponding C# class that will be responsible for reading and saving this data in the specific format. Typically, we rely on reflection here to auto-generate this code for serializing the serializing data at runtime, with the reflection possibility to emit dynamically code during the program execution. But this obviously has an overhead, performance hit, and moreover it reduces the scenario when we can use such a code because reflection may be not supported on a given platform. So here we have super powerful new possibility. Based on some external files, during compilation we generate serializers and deserializers for a specific data format, and they are just compiled as any other type in your program. Another example of source generators will be any possibility to augment your original source code. So there is, for example, a primary constructor source generator available on GitHub, and with the help of the primary constructor attribute, it will add a primary constructor to every type that is tagged with this attribute. So you will have a partial class, it needs to be partial, then some fields inside, and if you mark this class is with the help of primary constructor, and you can add this source generator as a NuGet package, then after downloading this NuGet package as being part of the project, simply during the compilation, the primary constructor source generator will kick in, it will scan the whole project, it will find all the types tagged with the primary constructor attribute, and then it will auto-generate for you the constructor for those types that have this attribute, which will be in another partial class that is added to the solution, at least logically, and it will be then compiled. And in the end, we can have many other examples of source generators. So for example, there is a nice source generator that is just adding you constants at compile time that comes from the project file itself and from the solution itself without referring to the reflection. At compile time, we can have access to some constants defined in the project file, for example. Or even there is very nice strong inject project, which is about compile time dependency injection. So instead of relying on the reflection again to at runtime bind all the dependencies, here at time of the compilation we are binding all those dependencies on the basis of the attributes that you have defined. So it is a compile time dependency injection. very nice thing. So let's return to this source generation story with the context of partial methods, because this is the topic of this lesson. So most source generators will add methods to a type because we are defining a partial class, and then source generator will add some additional methods, behavior to this type, which will be also in form of a partial class of the same type. But now we can also use this split between declaration and definition of a method with the help of partial methods. So, typical example, imagine a compile time regular expression generator. There is a method, it has some return time, it has some input, but then there is this attribute regex generated, which has a value of a regex that we would like to validate use for this particular method. And source generator can scan the whole file, the whole project for methods that has regex generated attribute and may generate, so implement the code for it to provide very nice, efficient, optimized regex machine, regular expression machine that will be responsible for matching this particular regular expression. So, first of all, we can get rid of reflection totally, because in a normal usage, regular expressions are compiled at the runtime to some machines that are emitted by the reflection. So here we can get rid of it totally. Moreover, we have more power because we can optimize things during compilation, so we are not limited in any way how complex is the optimization, because we are doing this once at compile time before the application is even run, which is super nice. So our custom source generator will find those attributes, generate a nice, efficient, probably efficient, at least I hope, implementation of those regular expression generator machine, and it will all happen during the compilation time. And this is possible because of this split. This is a declaration of a method. So we have an attribute, we have a return type, we can apply attributes to it, and then additional file will be created with the help of this source generator, and definition of it will be added. So there will be another part of this method with the implementation itself. And imagine more use cases. Your imagination is only the limit here. So for example, going to the same direction, you can imagine that you have a source generator that will generate efficient machines for calculating given math equations. So you have a mathematical equation here to be calculated in one or another form, like here it is about LaTeX mode. So it is just an equation of the relativistic mass, for example, and it now is just a declaration. We are saying, okay, I want to have a method that will take two arguments, m and v. It will return a double as a result, and it should return an equation, a result of an equation that I'm providing as a value of this specific attribute, and my source generation will be doing that. We'll be finding these methods with this attribute, taking this value, generating all the code for implementing this particular equation. Another example would be kind of saying I want to have a method that will describe my type with the given fields. So I will tag a method with, let's say, fields description generated attribute. I will provide the names of fields or properties that I would like to use as the values for description of the type, and my source generator will kick in and will implement the describe method with the usage of those fields that I provided here. You can go even further because what the source generator is doing simply, it is plugging into the whole compiler pipeline. So it is saying all the types, all the syntax of your code, names, types, everything. So you can use even convention like here, like for example, if I have a method which is called and named describe username and email, my source generator will find all partial methods that start with the name describe and take the fields to be used for the description from the name itself. You can imagine you are using this for builder pattern, for example, in your tests, or any other thing that you imagine will be nice to have in your application. So the sky is the limit when you are considering source generators, and partial methods are very nice addition that just allows to provide such a logic, to provide you a way of splitting declaration and implementation, so you can decorate your declaration, and by declaration you specify what behavior you would like to have added to your type, and then this will be added by your source generator. So this is it. There are some materials that you can follow. There are examples of source generators. There is even an online source generator, so you can play with them even without opening Visual Studio. A lot of examples, list of source generators. You can look around, because this is a topic, like source generator is the main reason here, but you can always meet some partial methods here and there when you will be seeing source generators, because this is, as I hope I showed you, nice way of using them.